So we're carrying on with this. What I'm going to do is get rid of that insulation infrared worksheet, if that's the right word. It's difficult list. Right, okay. Right, we know. What do we know? We know white surfaces are. Right, okay. Bad absorbers of infrared radiation. Radiation. And they are right, okay, and we now need to let's put on the other side. Black surfaces are good absorbers of infrared radiation and also the good emitters, yeah, on the other side. So we know that. Right, with this question, we've got two computer cases, right? This one has got a plastic case. It's a white plastic case. Right, straight away we know that's going to apply to it. We've also got a fan and hot air from the case inside is blown out. Right, so we're getting convection. There's a gap here, so that means that there's no conduction. So any heat is via convection. Now on the other hand, we have this aluminium case. We're going to assume it's a silver color, and we know it's made out of aluminium, which is metal. So metal, we can also write here. Metals are good conductors of heat. Conductors of heat. Right, if you look here, there's no gap. There's no gap here, so it's conduction. There's no fan, so convection is minimal. Aluminium. So what's going to happen is any hot air in here is going to get absorbed by the case, and then the chances are that will radiate it out. So efficient removal of heat. So most of this is via conduction, and most of this is via convection. That's what's going on. Right. Explain the main method of heat transfer from the chip to the surroundings for case X, and then B is part of Y. So we've just explained on that. We need to now put that into words. So if we look at A, and so what we can do is, right, for case X, convection is the main method of heat transfer. Right. The fan helps with, done it again, with convection. Right. And since the chip is not in contact with, done it again, with the fan. Just bear with me, I'm talking to myself again. Since the chip is not in contact with the fan, conduction is not the main method of heat transfer. Right. What else can we say? Yeah, okay, so remember they've said it's a white plastic case, so we can say the white plastic case is a pore absorber and then emitter of infrared radiation or thermal energy. What else can we say? I think that's it. Oh, it's also plastic. And also plastic is a pore conductor of thermal energy. Right, so what's going on? First of all, let's have a look. Convection is the main method of heat transfer. The fan helps with convection. Since the chip is not in contact, conduction is not the main method. The white plastic, because it's white, it's a pore absorber from the inside here, and then emitter from the outside of infrared radiation. And because it's plastic, it's a poor conductor of thermal energy, so you're not going to get much conduction, or very little. Now, with this, it'll be now the other way, right? So we can say it's exactly the same thing, but from the other point of view. Conduction is the main thermal energy transfer. So the method of transfer is that metals are good conductors of heat energy or thermal energy. The metal case will transfer energy via conduction and then radiation. what have they said? Right here, the aluminium is painted black. It's not silver, it's aluminium is painted black. Right, and we said earlier, so let's just use that. So the black case is a good emitter of infrared radiation. Yeah, so will help with the energy transfer. That'll do it. So what's happened, you said conduction is the main thermal energy transfer. Metals are good conductors of heat energy. The metal case will transfer energy via conduction, right, very efficiently. And the fact that they've painted it black, so the black case is a good emitter, absorber and emitter of infrared radiation. Right, we can just quickly do this and then state the power current voltage. I remember it as PIV. But remember we said we're going to write it out in fully in words. Power is current times voltage. We know power is measured in watts, current is measured in amps, and voltage is measured in volts. Yeah, so P equals IV. Got that there anyway. Right, a small computer operates at a voltage of 1.5 and a current of 2.9. Calculate the power. Give the unit. So we write the formula out. Just out of habit. Right, the more you say it, the more you will in the exam be able to. I've done it the wrong way around. It doesn't really matter that, but let's try to do it. So P equals 14.8 watts. That's it done. Right, we'll do the next one. Right, okay, we've only picked part D for this. It's to do with black and white surfaces, metal and non-metal. Right, okay. So what do we know? The color white is a poor absorber of infrared radiation and therefore is a poor emitter. Right, a black surface, if you keep repeating it, it'll sink in. A black surface is a good absorber of infrared radiation and a good emitter. Right, we can say metals are good conductors of thermal energy or heat energy. Remember, you've got conduction, which happens in solid. You've got convection, which happens in solids and liquids, and you've got convection, conduction, and radiation, which happens in, I think that'll be solids at this level. This is solid and solid silly person. Can't believe I did that. Right, just bear with me 1 second. I've got the man flu. So it's liquid and gases. Conduction is in a solid. Radiation can also occur in liquids, but you're mainly likely to get convection as things move around. Right, okay. So a fan cube spins and he's heated by the sun. So the sun fires off rays and it heats this white, shiny white metal bar and this dull. Right, so that's another thing. Shiny surfaces are bad absorbers of infrared. Dull are better. We'll come to that. Right, okay, so the temperature probes measure the temperature of each of the metal bars. Use the ideas of thermal energy transfer to explain how the temperature of each metal bar changes as it spins. So what's going to happen is this is going to spin, then this black and white bar are going to be on the opposite side, so then there's going to be no infrared radiation from the sun. We now need to, for 4 marks, explain that via talking about energy transfer, how the temperature changes. Right, we can say both bars increase in temperature when facing the sun. The black bar increases in temperature quicker or faster when facing the sun. Why? Facing the sun and reaches a higher temperature because black is a good absorber of infrared radiation. Right, what's next? Right, so now it's gone to the whole thing spins around, and now you've got the black bar at the top and the white bar at the bottom, and there's no direct sun hitting them. So as it spins, yeah. So now what we need to do is put that there so we can see the one. Let's go back to that. When the bar is on the opposite side and no sun is hitting the bars. Okay, when the bars are on the sun and no sun is hitting the bars, we've got to put the color in. The black bar will decrease in temperature quicker because black is a good emitter of infrared radiation. Right, then we're going to just add that conduction and convection, because it's asking for the types of energy transfer. Conduction and convection are not present. So yeah, it's not here. What I should have suppose written, because the first part, A, B, C, explain that they're in space. They're not on Earth. This is in space. So there's a vacuum. So there are no particles for conduction and convection. Conduction and convection are not present since they are in space. Since they are space and there are no particles outside the spacecraft. But right, that wasn't obvious here because I've chopped out the first part of the question. But look at this, it's a good one to look at, this one. Right, so both bars are going to increase when facing the sun, right, because they're going to absorb infrared radiation. The black bar is going to increase faster and reaches a high temperature. Why? Because black is a good absorber of IR radiation. First thing. Next thing, when it's on the opposite side and you've got no sun hitting, so when it's pointing away from the sun, the black bar will decrease in temperature quicker because black is a good emitter. Right, so we've put all that in. Now we're going to just finish it off with conduction and convection are not present. Why are they not present in this instance? Because they're out in space, and in space there are no particles. And that'll finish it off. Right, okay, we'll call it quits there. Do this on the next video. Okay, Jazakallah khair.